I will be speaking in my role as a co-leader of work package 4 of eDNAqua-Plan. The leader actually is Sophie Dericke, who cannot make it, unfortunately, but a lot of the work I present here is basically what she worked with the marine parts. I am mostly focused on the Water Framework Directive aspect, Sophie very much on the Marine Strategy Framework Directive. So maybe quickly, work package 4 is really the use cases. It's more like looking what are the requirements the eDNAqua plan folks propose, and can we actually make it usable with our data sets? And often we were just sitting there, it wasn't really possible, or we didn't know how to do it. And then we checked back with the other work packages, received recommendations. And so step by step, we realized what can work and what not. Yet, this is another step. This is about policy. If we step back one moment, this is something that I think is quite trivial. If you search for advantages of DNA and eDNA-based methods, eDNA now offers a wide range of applications, many of which will have interest and relevance to policymakers. Now is an important moment to consider how these recent advances in eDNA technologies can most effectively benefit society. So how can we bridge this? Academia, we love playing with the technology, to how does it actually make a change, or as Nick said it, how can it be transformative? This is one randomly selected example from the policy guide from the Royal Society meeting that took place just a year ago in the UK. If you're interested, look it up. It's a fantastic document. So the point is, we have solutions, but do they work in a regulatory monitoring context, which really differs from what many of us are doing? So the method requirements for biomonitoring or biodiversity monitoring in policy contexts often differ. So there are certain, I will try to switch on my laser pointer. There are certain method requirements that need to be considered, and they are often explicitly listed in annexes of the directives. And we will look at Marine Strategy Framework Directive from the year 2008 and the Water Framework Directive, which also covers coastal areas, from the year 2000. Especially, we will look at general, also procedure-wise fit of the method. So not only the data, but the type of data generated, and then more the aspects of data reporting, reference databases, etc., which largely links us to the final products, or the ecological or environmental status reports need to be finally transmitted to the WISE Marine or WISE Freshwater portal. And from there, we go back to the reporting steps. Let me briefly introduce the directives for those that do not know the directives. The Water Framework Directive really is a success story. As you will see, it aimed to have all the European water bodies in at least good shape by the end of 2027, which is not far from now. We are kind of stuck here at 38%. This sounds bad, and it's also bad, but that's not due to the a constant failure of the Water Framework Directive. The Water Framework Directive is also by the Commission evaluated really as a success story. We need to adjust it. We need to see how we can now finally really implement stuff to improve the water bodies. But the framework, as it is established, is a very, very good one. And we will focus on biological quality elements, which are used to assess the ecological state of water bodies. Especially, we will focus on benthic invertebrates, diatoms, and fish as key indicator species. So just to show you one aspect, in order to increase the 38% to 100%, is we need other directives. And you have probably heard about the Nature Restoration Law, which now really opens opportunities to really make progress also on the correctly identified, not good water bodies by the Water Framework Directive. And the fitness test, fitness check already says probably the directive needs additional, innovative, cost-effective methods to fill the gaps in the future. The monitoring purpose. Water Framework Directive has quite strict requirements due to normative definitions. So this is what's written here. You can just read all the details in our deliverable, but you have to have 5 distinct status classes. You have to have type-specific assessments for the different water bodies. You need reference conditions, and then you need the biological quality elements, different organism groups. And now there are 2 points which are important. You should have composition and abundance, and possibly for some BQEs also biomass and age structure. Then boundary setting, you have to set the boundaries between the status classes, yes. And this is now very interesting. The Water Framework Directive in the normative annex specifies you have to use formal standards. A standard is not the protocol you use in your lab. It's a document developed by a standardization publishing agency or entity like ISO or CEN-ELECT. And of course, the reporting is also a duty. Report the final data to a central database, which is here WISE Freshwater Information System. For the Marine Strategy Framework Directive, it's a bit less strict. So here the goal is to achieve by the end of 2030 an at least good environmental status of the monitored marine habitats. And to do that, 11 qualitative descriptors are used with primary and secondary criteria defined in the Commission decision from the original one from 2008 and the update from 2017. National thresholds and regional cooperation is sought for this directive, and the reporting follows also in a WISE portal, which is different, the WISE Marine portal. If you look at the different descriptors, which is kind of the BQEs of the Water Framework Directive, are here the descriptors. There are the various descriptors, the 11 ones, and then there are the criteria how you should assess them. For example, non-indigenous species do not adversely alter ecosystems, and criteria to assess that are described here. And you already see for some of these, there's a 1, and 1 means that's easily possible to just replace with DNA methods. A 3 means it will not be possible, likely be not possible in the near future to replace this with DNA methods or eDNA methods. 2 means probably possible, but more work needs to be done. So you see, it's not straightforward for some of the descriptors. And one key issue also is, whereas the Water Framework Directive is really strict on these standards and really put a lot of pressure on member states to harmonize the methods across member states, we here have already in the 2017 a check of the Water Framework Directive that it's necessary to clarify, revise, introduce criteria, methodological standard specifications in order to make things comparable. And this has still not been fully implemented. So it's much less strict because it wasn't implemented from the start. Now, let's ask the question, can eDNA and DNA methods play a role here? Some people say never change a running system. It was so stressful to implement these methods. Now continue with the traditional methods. Or does it make sense to take up the DNA or other innovative methods? And if we look into the fitness check, for example, of the Water Framework Directive, experts have indicated that the uptake of novel technologies could be better and that some of the technical annexes are too prescriptive by prohibiting the uptake of new methods. Because that's also an identification, there seem to be, even in the Water Framework Directive, no legal barriers for such methods. But important is guidance documents would be needed to cater for such novel technologies because there's a lot of uncertainty. So what are then the roadblocks so far? And this is based on various discussions we had in our working group 4 of eDNAqua-Plan, but also in European Commission meetings under the working group EcoStat. And the elephant in the room often is abundance, biomass, age, and size. eDNA methods at the moment can, if you identify multiple species at once, not deliver upon that reliably. Sometimes roughly, but not really reliably. The lack of end-to-end standards. So there are no documents that really will guide people from collecting environmental DNA or DNA to a final assessment result. We need this urgently. Curated versioned reference databases are scarcely available, which limits the reliability or how trustworthy the taxa lists are. And of course, the interoperability of the reporting we use for our DNA-based reporting versus what Water Framework Directive or Marine Strategy Framework Directive requires can differ. So one point, and that's on the positive side, this may be less severe than we think. So recommendations are, that doesn't mean because we don't have now a fully standardized way that it's impossible to use the methods already now to complement the Marine Strategy Framework Directive and Water Framework Directive, because some standards exist and you can use them. We're just about to move the European standard for eDNA collection to the international level. It's at the very final stage. Other standards for diatoms, for invertebrates, on how to sample and how to store already exist. And in addition, many validated procedures also exist, guidance documents, which can be followed. While we have no globally unique, curated and versioned reference databases, there are curated reference databases for DNA barcodes which could be used. And of course, we have, in order to make things fair, INSDC, so International Nucleotide Sequence Database collaboration. In particular, eNA, we recommend the European Nucleotide Archive, where to store the sequence data for later checking of what was measured when reference databases are updated. So you already now can generate robust, reliable, and reproducible and reusable data, and you should do so. Not wait would be the recommendation until everything is fully standardized. So, coming to an end, what is the roadmap for the next 5 years? Engage with the relevant groups that are in charge of implementing those procedures into the directives, which is EcoStat in the case of Water Framework Directive and the working group Good Environmental Status for the Marine Strategy Framework Directive, in order to co-develop with them how to integrate DNA-based methods. Advanced SEN and ISO standardization for those directives. And good progress has been made. EcoStat WFD has this group established and the links. We have standards on the way. Now essential, complete reference databases, make them reliable, systematic data deposition, and eNA in particular. And this requires also training. And we also developed simplified submission workflows and data management plans to enrich the data with the required metadata proposed by eDNAqua-Plan. Then, of course, to really make it happen, and eDNAqua-Plan thinks long-term and sustainably, we cannot just implement the new methods, we need to intercalibrate them. And we don't have to reinvent the wheel. Intercalibration procedures are established for the Water Framework Directive. I must admit, I'm not 100% sure how that is for the Marine Strategy Framework Directive, but there are guidance documents and it's possible to do so. We definitely need end-to-end analytical and fair data publishing pipelines to support the non-bioinformatic experts to use that. And we should also develop DNA-specific indicators, not just rest with the past indicators, but use the power of DNA to develop more. Of course, institutionalized training and capacity building at European level. Key takeaways from a work package 4 perspective: DNA and eDNA methods are already now ready for operational use for several aspects of Water Framework Directive and Marine Strategy Framework Directive monitoring. The great thing is, if you have then environmental DNA, you can do more than just, for example, fish monitoring. You can go to the bacteria, etc. pp. So dual, triple, multiple data use options exist, which is good for up to the global biodiversity framework, global biodiversity framework reporting. And for sure, the methods will become integral once we have standards, curated reference databases, things intercalibrated, and interoperable reporting. But the future is not now. We should not wait for that. The longer we wait, we run at risk that methods will further divert. We really must work now on implementing that, and eDNAqua-Plan is doing a great job, I think, here. I'm just part of the use cases, and I can just applaud my colleagues for doing the job. Thank you.